Right now, two massive wildfires are tearing through Georgia, burning across more than 77 square miles and pushing dangerously close to nearly 1,000 homes. Entire neighborhoods are on edge as flames move faster than crews can contain them, turning dense forest into walls of fire in a matter of hours. Officials have already declared a state of emergency, but even that may not fully capture how quickly this situation is escalating. From the ground, the reality looks even worse. Homes reduced to ash, highways surrounded by smoke, and entire communities preparing for possible evacuation at any moment. Fire crews are working around the clock, but containment remains extremely low and the fire keeps spreading. At first glance, this looks like another wildfire disaster driven by heat and drought. But what's unfolding here is far more complex. It's because the real story didn't start with the flames you're seeing now. It started long before this fire ever ignited. And once you understand what actually set the stage for this, the scale of what could happen next becomes far more concerning. Stay with this update as we break down what's really happening on the ground, and why this wildfire may be far from over. Subscribe to follow the latest developments as this situation continues to unfold. On the ground, the situation is unfolding in real time, and it's far more intense than the numbers alone suggest. Entire stretches of forest have already been consumed, leaving behind blackened land where thick green canopy once stood. In some areas, the fire has moved so fast that residents had only minutes to gather essentials before evacuating. What remains are burned structures, damaged roads, and a landscape that no longer looks familiar. More than 100 homes have already been destroyed, and hundreds more are sitting directly in the projected path of the flames. Fire lines are being pushed back again and again as winds shift direction, carrying embers deeper into untouched areas. This is not a slow-moving wildfire, it's unpredictable, aggressive, and constantly changing. Crews from dozens of departments are working simultaneously, supported by air tankers and heavy machinery, yet containment remains critically low. That means the fire is still largely in control of where it goes next. And as this continues to spread, one reality becomes impossible to ignore. This isn't just about what's burning now, it's about everything still waiting for the next spark. This isn't just about what's unfolding, it's about the safety of people, and every living being affected. Leave a 9 below to show you repaying attention. What makes this situation even more unsettling is how it all began. Not with lightning, not with a massive explosion, but with something so small, it almost feels impossible. One of the fires started when a foil party balloon came into contact with a power line. The other was sparked by routine welding work, a few stray sparks from a resident working on a gate. Two ordinary moments, two minor ignition sources that under normal conditions would likely have caused little to no damage. But this time, everything was different. It's because these fires didn't grow simply because they were ignited, they grew because the environment was already primed for disaster. The forests weren't just dry. They were loaded with material ready to burn, waiting for even the smallest trigger. And that changes the entire perspective. This wasn't a case of something unusually powerful causing destruction. It was a case of something incredibly small meeting something dangerously prepared. Which raises a far more important question: what exactly turned this landscape into something so ready to ignite? To understand why these fires escalated so quickly, you have to look beyond the ignition point and focus on what was already in place. Because the real driver here isn't the spark, it's the environment that received it. Across southeast Georgia, the forest floor has been quietly transforming over time. What once acted as a natural barrier against fire has turned into a dense layer of dry, fallen material. Trees that used to hold moisture and slow down flames are no longer standing. Instead, they've become fuel spread across vast areas, interconnected and highly flammable. When a spark lands in conditions like this, it doesn't just start a fire. It activates a chain reaction. Flames don't move randomly, they follow fuel. And here, that fuel is everywhere. It allows the fire to travel faster, burn hotter, and resist early containment efforts. Even experienced crews find it difficult to establish control lines when the fire can reignite and spread in multiple directions at once. This is where the situation shifts from a localized incident to a large-scale event. Because once the environment itself becomes the accelerator, stopping the fire is no longer just about response, it becomes a race against the conditions already set in motion. To fully understand why this wildfire is behaving the way it is, you have to go back not days, but months. In fact, back to September 2024, when Hurricane Helene swept across Georgia and fundamentally changed the landscape. The storm didn't just pass through. It tore down vast areas of forest, leaving behind an estimated 14,000 square miles of damaged land. More than 56 million tons of trees were knocked to the ground, pine and hardwood alike scattered across the forest floor. At the time, it looked like storm damage. But over the following months, something else happened. Those fallen trees began to dry. What once held moisture became brittle, lifeless, and highly flammable. Layer upon layer of dead wood remained in place, forming a continuous field of fuel stretching across entire regions. Cleanup efforts were launched, and millions were spent trying to remove debris. But the scale was simply too large. Even after a year and a half, much of that material remained untouched. Fire experts have a term for this kind of environment, a tinderbox. And that word isn't to use lightly. Because in a tinderbox, fire doesn't need strength to grow. It only needs a spark. Now add the numbers behind this situation, and the scale becomes even clearer. Nearly the entire state of Georgia is currently under drought conditions, with around 98% of the land classified from moderate to exceptional drought. That means moisture levels are critically low not just at the surface, but deep within the soil and vegetation. At the same time, fire indices in the affected area are approaching levels that signal extreme resistance to containment. In simple terms, once a fire starts under these conditions, it becomes significantly harder to stop. Flames burn hotter, spread faster, and continue even through areas that would normally slow them down. Weather patterns are making this worse. Temperatures have been above average, humidity remains low, and strong winds continue to shift direction, pushing flames unpredictably across the landscape. Forecasts show that meaningful rainfall is not expected until midsummer, leaving a long window where conditions remain highly favorable for fire activity. So when you combine drought, heat, wind, and millions of tons of dry fuel already on the ground, you don't just get a wildfire. You get a system under pressure, one where even a small change can rapidly escalate into something much larger. What makes this situation even more striking is that it wasn't unexpected. In fact, just 1 week before the first fire ignited, its federal and state forecasters had already outlined the exact conditions needed for a major wildfire event. They pointed to 3 key factors: prolonged drought, unusually dry and warm weather, and a massive buildup of dead vegetation left behind by Hurricane Helene. Individually, each factor increases fire risk, but together, they create a scenario where ignition becomes far more likely, and spread becomes extremely difficult to control. That warning wasn't vague. It described a precise setup: dry fuel, dry air, and the potential for wind-driven fire behavior. And when the fire started, those exact conditions were already in place. In other words, this wasn't a surprise. The fires we're seeing now are not random events, they are the direct result of a known and identified risk coming into alignment. The ignition may have been small, but the outcome followed a pattern that had already been mapped out in advance. Which raises a critical point: when the warning is this clear, the real challenge isn't prediction, it's whether the system can respond in time. Right now, the situation on the ground remains highly unstable. Despite the scale of the response, containment levels are still critically low, hovering around single digits in some of the hardest hit areas. That means the fire is not under control. It's still moving, still expanding, and still finding new fuel. In Brantley County alone, hundreds of homes remain directly in the path of the flames, while additional properties in nearby counties are now at risk as conditions shift. Fire crews are working in coordinated operations, supported by bulldozers, air tankers, and multiple agencies. Yet progress remains slow due to the intensity of the burn. What makes this even more difficult is how unpredictable the fire has become. Changing winds can redirect flames within hours, sending embers far beyond existing fire lines and igniting new spots unexpectedly. This is no longer a contained incident, it's an active and evolving emergency. And as long as conditions remain dry, with fuel still covering the ground, the fire doesn't need to restart. It only needs to continue. To understand where this could be heading, it helps to look at what has happened before. In 1989, Hurricane Hugo struck the southeastern United States and left behind millions of acres of damaged forest. At first, the focus was on the immediate destruction. But in the years that followed, something else emerged. The fallen timber became fuel. Even after large-scale cleanup efforts, the affected regions experienced elevated wildfire activity for several years. Researchers later confirmed that the leftover debris played a direct role in increasing both the frequency and intensity of fires long after the storm had passed. Now compare that to Georgia today. Hurricane Helene caused widespread forest damage on a much larger scale, leaving tens of millions of tons of dead wood across the landscape. And unlike Hugo, only a portion of that debris has been removed so far, which means the current fires may not be an isolated event. They could be the early phase of a longer pattern, one where the impact of a single storm continues to unfold over multiple fire seasons. Looking ahead, the timeline becomes just as important as the fire itself. In southeast Georgia, its fire season doesn't end soon, it stretches through October. And right now, forecasts show no significant rainfall expected until midsummer. That leaves a long window where conditions remain dry, unstable, and highly favorable for continued fire activity. The key factors haven't changed. The drought is still in place. The fuel from fallen trees is still covering large areas of forest. And the weather pattern continues to support fire growth rather than slow it down. So what we're seeing now may not represent the peak of this crisis. It may only be the beginning. Because when a landscape holds this much fuel, under this level of dryness, the risk doesn't disappear after one event. It stays waiting for the next ignition, the next shift in wind, the next moment where conditions align again. This is an evolving situation with real consequences. Subscribe to stay updated as we continue to track what happens next.